Well, that was fun. I guess we'll do two parts to this video, so I don't have to start over. It just disconnected me. So let's work on number 2. I need to find two factors of 80 that are going to add to negative 18. So if I list all of them, 1 and 80, 2 and 40, think of all of them here, 8 and 10. This one's going to work. Actually, I can already see it. I need two numbers that need to add together to give me negative 18. And if I multiply them together, I get a positive 80. So if I'm trying to get a negative number in the middle and a positive when I multiply, I know my signs have to be negative, both of them. So negative 8 plus negative 10. So when I write this on here, it's going to be x minus 8, x minus 10. All right, how about this other one? I already gave you a hint about this one. I wrote the word ugh right there, but can you do this one? We've done anything so far to factor how to do this one, and I want you to notice what's different about this one between the first two that I just did. So if we look, this has a 3 as my a, because remember a is my number in front of x squared. Both of these have a 1 as our leading coefficient. So the method that I've learned so far won't work for one like this. This method only worked for those two, ones like that. So we need a new method here that will help us solve equations to factor them that have a leading coefficient other than 1. And we call this the greatest common factor method. First of all, what is a greatest common factor? This goes back to, I don't know, a grade, 6th grade, 7th grade. And it's where I have a number, and it's the biggest number that will go into both of them. So the largest number divisible, let's see, that will divide evenly. And I said both of them, but what if there's 3? So let's put that will divide evenly for all of them, all of the numbers or expressions. So sometimes, I guess what I'm trying to get at here, I know you can't see everything I was writing, is that it's not always a number either. I'll show you why here in just a moment. So let's find the greatest common factor of the following pairs of numbers by listing all the possible factors that go into each number. Well, we can look at this, and I know that 1 and 4 and 2 and 2 go into 4. And on 10, I have 1 and 10 and 2 and 5. So the greatest possible factor, the biggest number that both of these share, is the number 2. Let's try 9 and 33. So I have 1 and 9, 3 and 3. 33, I have 1 and 33. I have 3 and 11. I think that's it. So the biggest number is 3, because I don't have an 11 on both, I don't have a 9 on both, and I don't have a 33 on both. So 3 would be the greatest common factor. Number 3. I think now we got the point. We don't have to write the factor trees, but this one, the greatest common factor would be 5. Because 10 doesn't go into 35, so that can't be my greatest common factor. What about 7 and 13? Most students say, well, several say none. But if I were to list the factors, I have 1 and 7, 1 and 13. So what's the biggest number that goes into both of them? It's actually 1. 44 and 64. This one, 4 and 11 is the first one I think of. Boy, I don't want to have to get out my calculator. 64 divided by 4. Shoot, I have to pull out the calculator here. 64 divided by 4 is 16. So I know I have 4 and 16. So we can see if 16 goes into 44. I know it doesn't, but if you don't believe me, you can put it in your calculator. 11 doesn't go into 64. The next one I might think of is to try 8, but I know 8 doesn't go into 44. So my biggest factor here is 4. You can list all the factors if you want, but for the sake of time, you can pause the video if you want to do that, or just trust me. Find the greatest common factor of the following pairs of variables and number combinations. So this time it's not just numbers that can be greatest common factors, it can also be letters or variables. So between x and x times y, the greatest common factor between both of them would be x. On 7, between a squared and a, the greatest common factor would be a. A times b times c is one factor, and then a squared times b squared times c squared is the second factor. So the one thing that they both share would be a, b, and c, would be the greatest common factor. Number 9, now I have a number and I have variables. So let's look at the first one. They both share a 3, so I can say 3. This one has an x, but that one doesn't. This one has a y, and so does that one, so I can say y. This one has a z, but that one doesn't. And this one has an a, but that one doesn't. So 3y would be the greatest common factor. And then the last one, x squared and 9x, the greatest common factor would just be x. When I pull out a greatest common factor out of a polynomial expression, I have to write what is left in the parentheses by dividing all the terms by that factor, by that number. So here's an example. If I had 5a squared minus 15, the greatest common factor here is 5. So if I'm trying to factor this, I would write 5 out front of the parentheses here. Now, how do I know what's left inside? Well, I have to take each term, so a squared, 5a squared, and divide it by my greatest common factor, which was 5. So I just got a squared. So left here was a squared. And then if I took negative 15 right here and divided it by 5, which is what I did right here, I got negative 3. So that's how I know what's left inside the parentheses. Once you pull out that greatest common factor, it comes out front, and then you divide everything inside the parentheses to find out what's left. Let's try this. So here we go on number 1. I have a 2y and a 6xy. So if I look at both of those, I know I can take out a 2y. Now be careful. This is a mistake I see all the time. Now I have to divide every term by 2y. So I would have what's left here. So my original term was 2y plus 6xy. If I pull out a greatest common factor, that means I'm dividing everything by that. So let's divide 2y by 2y and 6xy by 2y. And I get, what is 2y divided by 2y? I hear a lot of people say 0 or nothing or it disappears. But that's not true. Anything divided by itself is 1. Okay, and then I'm going to add. Now 6 divided by 2 here is 3. And then I have an x that stays there. And then I have a y divided by a y. Well, those cancel out. So y is gone. So it would be 1 plus 3x would be left inside here. 1 plus 3x. Let's try number 2. My greatest common factor between these two is 5q. So I take 5q and I pull it out front. And then leave my empty parentheses there. Now I'm going to take 10q minus 25q squared, and I'm going to divide both terms by 5q. Some of you guys can start doing this in your head pretty fast, but if not, keep doing it like this. So 10q divided by 5q, well, my q's cancel out because I'm multiplying by q on top and dividing by q on bottom. So then I'm left with 10 divided by 5, and that is just 2. And then I have negative 25 divided by 5 is negative 5. And then I have q squared divided by q. If we remember our exponent rules, this is like q to the first. So when I divide, I subtract exponents. So 2 minus 1 would leave me with just a q to the first on top. And since q squared is bigger than q to the first, that's also another clue that my q remains on the top of the equation. So it's just 2 minus 5q. Number 3, let's try to do number 3 a little bit more without having so much work. So I'm going to pull out, the greatest common factor between the two of those is 9. So if I take 81 and divide it by 9, I get 9. If I get 36 divided by 9, I get 4, and then just xy was what was left inside. Number 4. The greatest common factor here would just be 2 because 6 doesn't have an x, so I can't pull out an x. Only thing I can pull out is a 2. So that means I have to divide every term by 2 now. So I would have x squared minus 2x minus 3. All right, now look at this. Here's your challenge question. Keep your eye on this right here. After I pull out the greatest common factor on number 4, so I'm just going to rewrite it right here, x squared minus 2x minus 3. Is there anything else that I can do? It says a hint here. Look back at the one from the review. Did I have one like that on the review? X squared minus 2x minus 3. Oh, now I gotta find my review. X squared minus 2x minus 3. Oh, maybe I don't have one like that on the review. That would have been smart for me to do. Almost one like that. Have we seen one like this before? If I cover up this 2 out front, if I cover that up, have I factored an equation that looks like that before? With a 1 in front of the x squared? How did I do that? Well, I took 2 factors of c that added up to b. And yes, I can keep going on this. What I like to do is say, this little greatest common factor out here is like your friend at lunch that won't ever go away and just keeps coming back. So we try to ignore them. So we'll move it down here for a minute and just pretend like it's not there, but it never does really go away. That's how our friends work, right? So then I need to find 2 factors of 3 that can give me negative 2. So I need to find negative 2 in the middle. So I'm going to make this positive and this negative. So I would have x plus 1 times x minus 3. So I just took my greatest common factor out first, and then I factored just like what I did the other day. Just a 2-step equation this time. And yes, we can do that. Let's try number 5 and see if this one works. If I take out a 3, I'm left with x squared minus 6x plus 20. Is there anything I can do? So let's take our loner friend and pretend like it's not there for just a minute. Let's list all the factors of 20. I'm going to write it up here. So I have 1 and 20, 4 and 5, 2 and 10. And, I'm just not seeing any combination that's going to give me negative 6 in the middle. So on this one, I would just leave it just like this and stop right there. We only keep going if we can. Let's try number 6. So pull out a 5, and I'm left with x squared plus 3x minus 10. Now this one I've seen before. I'm going to take my little friend, put him or her down there, and then I have 10. So 1 and 10, 2 and 5. How am I going to get positive 3? I'm going to take 5 minus 2. So that would be x plus 5, x minus 2, and then our friend, even though it's a little lower here, is still multiplied out front. Now I can FOIL this all out and double check that I get back to there. I can distribute my 5 and then FOIL it, or I can FOIL these 2 and then times by 5. Either way, I will get back to this answer. So it still works. 7. Let's pull out a 4. So I'm left with x squared minus 4x plus 3. Now my little friend comes down here, and I'm going to ignore him for a minute. And I need 3 to multiply to 3 and add to negative 4. Well, I can do that by making both of those negative. So I would say, I'll make sure I line up this time. So put it right here. X minus 1, x minus 3. So my whole answer, don't forget about your friend, still out here. X minus 1, x minus 3. Okay, number 8. Pull out a 2, and I'm left with x squared minus x minus 42. Now, do I have 2 factors of 42 that are going to add together to give me a negative 1? During class, this was a very much missed problem, but let's think about 42. I can list them all. 1 and 42, 2 and 21. I know the right one I'm looking for is 6 and 7. Can I get a -1 somehow using 6 and 7? Yes, I can. X plus 6, x minus 7. And so this would be my answer right there. All right, here's the objective quiz. See how you did? So I'm going to pause this quickly, let you work on these. So, well, actually, you're going to pause this so you can do this. Of course, this isn't being scored if you're watching this online. You just want to see how you did. See if you can score above 80%. So pause this, do these 5 problems, and then check back. Let's see how you did. All right, here's my answer. So number 1 is 4 times x plus 5 times x minus 2. Number 2, now if you're like me, you might have written x because we get used to writing x's, but so I had to go back and write a t there. But it's 2t times t minus 3 times t minus 4. Number 3 would be 3m, m plus 2, m plus 10. Now number 4, all I had to do on this one is pull out a greatest common factor. There was nothing I could do on the inside, so I stopped right there. And then number 5, I pull out a 3, and I have n minus 5, n minus 4. So write your score. Of course, if you get all 5 right, you got 100. If you got 4 out of 5, you got 80. 3 would be 60, 2 would be 40, and 1 would be 20. And so you're shooting to get 80%. If you didn't get 80%, I would go back, watch a few more things on the video, make sure that you know what you did wrong so that you can fix it and ask your teacher.